topics of mathematics. I would like to start with some basics just for fun, and then in the later videos maybe I will touch some harder topics as well. So yeah, thank you for visiting my channel, and let's get into the chapter 1, which is called the natural numbers. So, what are natural numbers? Natural numbers are numbers with which we count objects, such as 1, 2, 3, 4, 10, 20, 100, 1,000,000, so on. Obviously, there are infinitely many natural numbers. I have written some of them here on the blackboard, as you can see right here. I will start with some theory, and later I will also solve some problems which will include addition, subtraction, multiplication, and division with natural numbers. So first of all, I believe that knowing the theory in mathematics is crucial for problem solving. Problem solving becomes much easier when you actually hear some theory first. So yeah, that's my plan here. So yeah, let's start. I just need to get my pen ready and we're good to go. So let's go. Natural numbers. So there is a sign, a capital N with two lines here, which is used for the set of natural numbers. So this is a set which contains every single natural number, starting from 1, 2, 3, 4, and so on. Obviously, I will not be able to write every single natural number here. I do not have enough time for that. I know some countries use or have the number 0 included in this set, but that's just in some countries. I do like to use a different notation. So this is like the set of natural numbers including 0, which has the number 0 included. So obviously when we count things, we can say 1 apple, 2 apples, 5 trees, 8 billion people, but with that we can kind of also say 0 things, right? Although this set is called the set of natural numbers, while this set is called the set of whole numbers. So set of whole numbers. The only difference is the number 0, obviously, as I mentioned before. So what can we do with natural numbers? We can do 4 different things here. We can add them together, we can subtract them, we can multiply, and we can also divide the natural numbers. So for addition, so I'll just make a point here, addition. So we add two terms together, term plus term. variables, and the result is called the sum of the numbers, or in this chapter, the natural numbers. These two terms also have some special names. The first term is often called addend or cement, and so is the other term. So we can also write these two as addends or cements. So for these two or terms, they're totally good. That's the addition. The second thing we can do is subtract two numbers, so we get subtraction. Subtraction, and in this case we have a term minus term, and the result in this case is called a difference. Alright, so these two terms here also have some special names. The first term is often also called minuend. So minuend, while the second one is often called subtrahend. So subtrahend. And that's the subtraction. We also have two more, obviously. The third one is called multiplication. That's the third operation. Here we do not have terms, but rather we have two factors. So we have one factor times the other factor, and the result here is called a product. Yeah. These two also have some alternative names. The first factor is usually sometimes called a multiplier, while the second one is sometimes called a multiplicand. Also, yep, that's what I wanted to say here. Now for the final operation, I'll probably move that up here. The final operation is called a division. So here we have a dividend, and the second term is called a divisor. So the result is called a quotient. Alternately, these two are called numerator quotient is sometimes also called a fraction or ratio. So these two words too often appear in some exercises as well, but I like the word quotient the most. So that's pretty much all the theory you need here. While working with natural numbers, there are some rules just here under the natural numbers. Obviously, the first term in the subtraction must be bigger than the second term if we are working with natural numbers. Otherwise, the difference would be negative, which is not a natural number, as we can see up here. And also for the division, we need to be careful. The quotient might not be a natural number. So this quotient can also be a real number, let's say, or a decimal number, obviously. So we are talking about natural numbers here. So these are like some extra rules we need to be careful about here. Alright, so let's touch some problems now. Alright, I have some problems ready. The first exercise is going to be called column addition. Column addition. And column addition is a very useful method to add two big numbers together very fast. All you need is a piece of paper and a pencil, a pen. So the first one, we have 2037 plus 3711. So this will be the easiest exercise. Just to explain how column addition works. So first of all, we'll need to write these two in a column. So I will write a line here. Or maybe just like that. So first we write 2037, and then we add a plus here. And right under this number we write the second number, which is 3711. And we draw a line right here. And now we can just add the columns together, which in this case is very simple. We have 1 plus 7, which is 8, 1 plus 3, which is 4, 7 plus 0, which is 7, and 3 plus 2, which is 5, and that's our result here. So the sum of these once again, we write these two numbers in a column. We have 79282 plus 37281 and the line. Alright, so let's add these columns together. We have 1 plus 2, which is 3. And now we have 8 plus 8, which is 16. But we can only really write one digit number here. So number 16 is a 2-digit number, but we only have to write one digit here. So what we do in this case is we take the 6 as the number here and we write the 1 right up over here. Okay, so what we do in the next column, we add 3 numbers together instead of 2. So we have 2 plus 2 plus 1, which is 5. And now again we have 7 plus 9, which is again 16. So we need to write 6 here and 1 up here. And once again we have 3 plus 7 plus 11 plus 1, sorry, which is 11. So 11, we write the 1 here and move this 1 right here, and 1, the sum of 1 is just 1. And that's our result. 116,563. These are our results, our sums from exercises A and B. Alright, let's move to the next one called C. This one will be a little bit bigger. I mean, the numbers are just growing at this point. We will have 3,033,036 plus 29,371 and plus 3, which is 12. We write a 2 here and 1 in the next column. 2 plus 3 plus 1 is 6. And then we have 0 plus 0, which is 0, and 0 plus 3, which is 3, and that's our result here. That's 3,062,407. Alright, so just write this a little bit clearer here. Yeah, that is the sum of these two terms. Alright, next one. Alright, once again, the numbers are getting slightly bigger, not in this case. This one is just going to be two 6-digit numbers being added together. So we have 200,452 plus 378,321. So let's add these two together. Now, these two numbers have the same amount of digits, so we will not need to be careful about this case in the previous exercise. We can just write these two in a column without any issues. Alright, so 1 plus 2 is 3, 2 plus 5 is 7, 3 plus 4 is also 7, 8 plus 0 is 8, 7 plus 0 is 7, and 3 plus 2 is 5. This one was very simple. So 578,773. That's the result here. Alright, I have 2 more exercises prepared for the column addition. So we're moving to the exercise E here. We have 552,899 plus 46,899,938. 899,000, sorry. And these numbers are already hard to pronounce for someone whose English is not the first language. Alright, so far this is the biggest number we've had, 46 million, and the rest. So I personally like to write the bigger number first, but it doesn't really matter. Just how I solve these problems myself. So 46, 46, 8, 9, 9, 3, 8 plus once again, these two numbers have a different amount of digits. This one has 6 digits. This one has 8 digits. So we need to write the 5 here. So 552, 899. Here's the line. And okay, we have 9 plus 8, which is 17. 9 plus 3 plus 1, which is 13. 8 plus 9 plus 1, which is 18. 2 plus 9 plus 1, which is 12. 5 plus 9 plus 1, which is 15. 5 plus 8 plus 1, which is 14. 0 plus 6 plus 1 is 7. And 0 plus 4 is 4. And that's our result here. 47,452,837. That's the result here. Alright. And the last one in the first exercise. F. Alright, we will have a real big number here. We have 6,729,000 sorry, 93,987 plus 92,323. Alright, yeah, that's a big number, right? This one has 10 digits. It's 6 billion. And a little bit more than that, yeah. The second one is just a 5-digit number. So I'll write the bigger one here. Just make sure I wrote that correctly. Yes. And now the smaller number, this one has 5 digits. So we write it under here. 92323. And the line here. Oh yeah, by the way, I'm using a graphics tablet and I'm not really used to it so well, to be honest. I'm still getting used to it. I hope I don't mess it up when writing for too long. Okay, let's do this. 3 plus 7 is 10. 2 plus 8 plus 1 is 11. 3 plus 9 plus 1 is 13. Top 2 plus 3 plus 1 is 6. 9 plus 9 is 18. 0 plus 0 plus 1 is 1. And then for the rest we can just write these 4 digits down. And that's the result here. So 6,729,186,310. That's the result for the final exercise of the column addition. Alright, we still have a lot of exercises left. I believe it's better doing too much exercises than not enough. The more the better. Obviously, you're free to watch as many as you would like. You can also skip some examples if you think you already mastered. For example, the column addition. You don't need to watch all the examples. But yeah, let's move to the second exercise. subtraction, it will be very similar to the column addition. So this time we have two numbers, we have two terms, and we are looking for a difference. The A exercise, we have 80,989 minus 1,606. And yeah, we are looking for a difference here. So in column subtraction, it is very important to write the leftmost number here first in the column, like this, and writing the minus sign here, and the second number, the rightmost number, comes below the first one, like this. Alright, this is very important. And just like in column addition, this time we will subtract these two numbers, but this time we need to say, instead of we said 6 plus 9 in the previous exercises, this time we say 9 minus 6. So we start from up here and we subtract these two. So 9 minus 6 is 3. 8 minus 0 is 8. 9 minus 6 is 3. And 8 minus 1 is 7. And that's our result here. 7,383. Okay, good. Exercise B. Once again, these exercises in the column subtraction are going to get harder and harder, but it will be nothing you couldn't really understand. I bet it will be very clear after these 6 examples here. So we have 29,303 minus 7,372. Alright. So let's solve this one. Alright, once again we see this first number has a different number of digits than the second one. It has one more digit, right? So once again, just like in the column addition, we need to be careful about that. We have to write the left number first. Minus. Alright, this is a 4-digit number, so we need to write a 7 under the 9. And then 3, oops, 7, 2. This is a 3. Alright, let's go again. 3 minus 2 is 1. Now, there is a special case. As we see, this number is smaller than 7, so 0 is smaller than 7, and if we subtract 7 from 0, we will get a negative number, which is not a natural number, and that is a problem. So what we do here, we increase the top number by 10. So we write, we see this 0 as 10, and we, maybe I'll write it like, so this is a 10, because we add 10 here, because originally 0 is smaller than 7, and then we subtract 10 minus 7 is 3. So we have 3 minus 4, and this is smaller. This 3 is smaller than 4. So we need to add 10 here as well, and then we will have 13 minus 4, which is 9. And because we added 10 here as well, we need to add 1 to this number, 7. And then we have 9 minus 8, which is 1. And 2 minus 0, which is just 2. And that's our result here. Okay, so alternatively, we can say instead of 3 minus 2, we can say 2 plus what is 3. So 2 plus 1 is 3, 1 here. And then we say 7 plus what is 10, and that's 3. And because we increase this by 10, we add 1 to the next number here, which is 3. This becomes 4, and then we ask ourselves what is 4? 4 plus what is 13? That's 9. We increased this 3 as well to 13, and we need to add 1 more to the 7 here. And again, 8 plus what is 9? 1. That's cool. 0 plus what is 2? And that's 2. So the result, 21,931. Alright. Let's go to the next example. We have 371,300 minus 38,100. Alright. And we will try to find the difference here. Okay, so the first number comes here, minus the second number. This one is 5 digit. Alright, good. And okay, I will try the alternative approach here. 0 plus what is 0? 0. 0 plus what is 0? Again 0. 1 plus what is 3? 2. Okay, once again, 1 is smaller than 8. So we need to add 10 here. And we ask ourselves 8 plus what is 11? 3. And because we added 10 here, we need to add plus 1 to this 3. And we ask ourselves again, 4 plus what is 7? And that's 3. 0 plus what is 3? 3. And that's the result. 333,200. So the trickiest part here is adding 10 when the first digit is smaller than the second one, and then adding 1 to the next digit under here. So this is really the trickiest part at the column subtraction. Alright. Example D. We have 7,301,830 minus 77,999. Alright. Let's solve this one. is 10. And okay, this becomes 10. So 10 plus what is 13? 3. And once again, 10 plus what is 18? That's 8. 8 plus what is 11? 3. 8 plus what is 10? That's 2. 1 plus what is 3? 2. And 0 plus 7 is 7, and that's our result here. So 7,223,831. Good. I have 2 more examples ready. So this one is going to be slightly easier than the previous one. So the example 102,012 minus 8,269. Alright, here is the first number, and here is the second number. Okay, 9 plus what is 12? That's 3. We add 1 here. 7 plus what is 11? That's 4. We add 1 here. 3 plus what is 10? That's 7. We add 1 here. 9 plus what is 12? That's 3. We add 1 here. 1 plus what is 10? That's 9. And 1 plus what is 1? That's 0. But we don't really need to write it, right? We know the result is 93,743. Great. The last example here. Oh, this is going to be a big number. We have 8,913,017,340 minus 79,882,394. Okay, what is that? Okay, we have a 10-digit number here, and we have a 8-digit number here. I just need to write these two down. I need to make sure to not mess it up anywhere. Let's see, 7, 9, 8, 8, 2, 3, 9, and 4. Okay. Okay. So 4 plus what is 10? That's 6. We add 1 here. 10 plus what is 14? That's 4. 4 plus what is 13? That's 9. 3 plus what is 7? 4. 8 plus what is 10? 2. 9 plus what is 10? 1. 10 plus what is 13? 3. 8 plus what is 11? 3. 1 plus what is 9? 8. And 0 plus 8 is 8. next one. Of course, this one is going to be a column multiplication. Column multiplication. Alright, great. First example. We will have 6,381,002 times 5. Alright. And what is that? So, when doing a column multiplication, we draw a line here. And then we multiply the rightmost number with each digit of the leftmost number here. So we start from here. We say 5 times 2 is 10. Write 0 here and 1 above. 5. And then in the next case, we don't say 5 times 1, but we say 5 times 0 plus 1. So this becomes 1. 5 times 0 is 0 plus 1 is 1. Okay, 5 times 0 is 0. Then we have 5 times 1, which is 5. 5 times 8, which is 40. So that's 40. But we can only write one digit here, remember? So we need to write 0 here. And 4 goes right here, above the next digit. And then this next digit, 3, that's 5 times 3, which is 15. And then we add 4 to the 15, which is 19. 19. But once again, we can only write the 9 here. We need to move 1 over above the 6. And that's the final one. 5 times 6 is 30, plus 1 is 31. And since this is the final number, we can write is 18. We have 18. 5 times 5, which is 25, plus 1, which is 26. And finally 5 times 3 plus 2, which is 17. So 5 times 3 is 15 plus 2 is 17. Great. Now the job is done with a 5. And now we have to do the same thing with the number 2 here. So we can pretty much ignore these numbers here now. They were just for our help last time when we worked with the number 5 here. Okay, let's start all over again. And we need to make sure to write the answers under this answer. So we have 2 times 7, which is 14. 2 times 3 is 6, plus 1 is 7. 2 times 5 is 10. And 2 times 3 is 6, plus 1 is 7. Okay, and once we have these two numbers, we need to add them together. So we basically did 3,537 times 50, and then plus 3,537 times 2. So 50 times this plus 2 times this, and now we need to add this together, obviously. So we have 4. We already know how to do column addition. This is 12, this is 9, this is 13, this is 8, and this is 1. And that's our result. Great. 183,924. So it's about right. Yep. So for example, if we had a 3-digit number here on the right, we would end up with 3 different numbers here, and then we would need to add 3 digits together, which would be a little bit more difficult. That's why I advise you that you always write the smaller number on the right. I mean, in addition, it doesn't matter which number you multiply with another, in which order. You just need, it's very convenient to write a smaller one to the right. Like for example, if I said on the first example here 5 times 6 billion, 6 million, and so on, I would need to pretty much add like 7 different numbers later, which would be, it would give us the answer, but it would take more time, and we kind of want to be quick when doing math. Like, time is everything in mathematics. The faster you are, the better you are. Alright. Next example. C. Here we have 74,800 823 times 540. Alright. Now remember last time when we added 3 numbers together, 2 numbers together, because this number which has a 0 in it. But yeah, we need to start with the leftmost number from the right number here. So with 5. And we start by writing two zeros under here and start working under 5. So 5 times 3 is 15. 5 times 2 is 10 plus 1 is 11. 5 times 8 is 40 plus 1 is 41. 5 times 4 is 20 plus 4 is 24. And 5 times 7 is 35 plus 2 is 37. Great. That's our first number. Now we need to work with the 4. So we write 0 here. And we multiply these numbers by 4. So 4 times 3 is 12. Yeah, I will once again delete this. So 4 times 3 is 12. 4 times 2 is 8 plus 1 is 9. 4 times 8 is 32. 32. 4 times 4 is 16 plus 3 is 19. And 4 times 7 is 28 plus 1 is 29. Great. And obviously, as I talked before about it, the last digit is 0. So we just multiply 0 by each number, which gives us 0, 0, 0, 0, 0. But yeah, I will not write it here. We just need to add these two together now. So we have 0, 2, 14, 4, 10, 14, 10, and 4. And that's our result. That's a funny number. 40,404,420. A lot of 4s here. Alright, next example D. Oh, this one is going to be long. Alright. 515,177 times 42,336. We are looking for the answer here. What is the product of these two factors? So the right number is a 5-digit number, so we will end up with the 5 numbers to add together for the sum, which will be the answer, the product. So it will take some time, but let's just start as we learned before. So we write the zeros here and start with the 4. 4 times 7 is 28. And again, 4 times 7 is 28 plus 2 is 30. 30, 4 times 1 is 4 plus 3 is 7. 4 times 5 is 20. 4 times 1 is 4 plus 2 is 6. And 4 times 5 is 20. Alright, that's a big number. So, the next digit is 2. 2 times 4 is 14. 2 times 7, sorry. times 1 is 2 plus 1 is 3, and 2 times 5 is 10. Great. We needed to work on 3 more numbers here. We have 3. We have. Let's first delete this again. Alright, so 3 times 7 is 21. And then we have 3 times 7 plus 2, which is 23. 3 times 1 is 3 plus 2 is 5. 3 times 5 is 15. 3 times 1 is 3 plus 1 is 4. 3 times 5 is 15. Alright. Now we will save a bit of time here, because since we already multiplied number 3 by this, we can just write 0 here, and then the remaining numbers here will be the same as the ones we wrote in one row before it. So this will be 1, this will be 3, this will be 5, this will be also 5, 4, 5, 1. As you can see, each row is getting shorter by 1 digit. Alright, this saved us some time. Yeah. 6 times 7. Okay, we are working with the final number now, so 6 times 7 is 42. Write it here once again. I need to erase this. 42. Again, we have 42 plus 4, which is 46. Then we have 6 plus 4, which is 10. 6 times 5, which is 30, plus 1 is 31. 6 times 1 is 6 plus 3 is 9. And then we have 6 times 5, which is 30. Great. Now, the final boss. We need to add these 5 numbers together, which is not gonna be too hard. So the first column is 2. The second one is 7. Third one, 4. Then we have 1 plus 5, which is 6, plus 3 is 9, and plus 4 is 13. And then we have here 10 plus 5 plus 5 is 20, plus 5 is 25, plus 8 is 33. So we add 33, and 3 goes here. And then we have 3 plus 4 plus 5 plus 3. Okay, so that should be 15. And then we have 1 plus 3 plus 5 plus 4 plus 7, which should give us 20. 20. Again, we have 5 plus 5 is 10, and then 3 plus 7 is 10, so in total 20. Here we have 2 plus 1 is 3, plus 3 is 6, plus 5 is 11. And then we have 1 plus 1 plus 6, which is 8, and here is just 1 and 2. Great. So, in total we have 21,810,000,000. Wait, what? No. This is 21 trillion. My bad. these are 6 and 5-digit numbers. But since we have 2 zeros here and 2 5s here, this example will be a bit shorter than the previous one. The previous one is probably the longest, to be honest. Out of these, it's just a lot of work, a lot of concentration needed, but it's pretty much doable. So let's start with 5 first, and write zeros here. We know 5 times 0 is 0. Once again, here 5 times 2 is 10. 5 times 8 is 40, plus 1 is 41. 5 times 3 is 15, plus 4 is 19. And 5 times 6, 30, plus 1 is 31. Great. Next number, we have number 3. So let's write zeros here. 3 times 0 is 0, and 1 more 0 for the next 0. And then we have 3 times 2, which is 6. 3 times 8, which is 24. 3 times 3 is 9, plus 2 is 11. And 3 times 6 is 18, plus 1 is 19. Great. Now we have another 5 here. Okay, we will write the 2 zeros here, but for the rest, we can actually just copy these numbers here down there, because the method will be the same. Just remember to start with the 0, because that's obviously where we started writing our results. So we have 3 zeros here, and then 1, 9, 1, 3. Okay. And then we just have 2 zeros left, and 0 multiplied by this is just 0. So we do not need to write 2 more rows full of zeros. We just need to add these 3 numbers together. Now, the first 5 columns will obviously be very simple. And the rest will not be too hard as well. So 7, this is 13. And then we have 4. We have 9 plus 9, which is 18, plus 3 is 21. And here comes 4, and here comes 3, and that's our result. Alright. That's 34 billion again. Okay. 143,370,000. Yep. That's our product of these 2 factors here. And the final example of the column multiplication, example F. This one will be, once again, interesting. We have 1, 2, 3, 4, 5 times 6, 7, 8, 9. Yeah, let's multiply this. So these are just all the possible digits written as a multiplication. So we know what to do. We start with 6 here. 6 times 5 is 30. 6 times 4 in this 12 plus 2 is 14. And 6 plus 1, which is 7. Okay, next one. 7. 7 times 5 is 35. 35. 7 times 4 is 28 plus 3 is 31. 7 times 3 is 21 plus 3 is 24. Then we have 14 plus 2, which is 16. And 7 plus 1, which is 8. Oops. Okay, next number 8. 8 times 5 is 40. Once again, let me delete these numbers which were meant for help. 40. 4 times 8 is 32 plus 4 is 36. 3 times 8 is 24 plus 3. That's 27. 8 times 2 is 16 plus 2 is 18. And 8 plus 1 is 9. One more. Number 9. 9 times 5. That's 45. Oops. 45. 9 times 4 is 36 plus 4 is 40. Yep. 9 times 3 is 27 plus 4 is 31. 9 times 2 is 18 plus 3 is 21. 9 times 1 plus 1, sorry, plus 2, that's 11. Okay, great. Now we need to add these four numbers together and we get 5, 0, 12, and we have 10. Oh, this is 21. And then 18, 13, and then 8. Okay. Let me check if that answer is correct. Since I have already solved these exercises before. And yeah, it is. It is, yeah. I just needed to double check. Because obviously this one is a long one and we are multiplying some higher numbers here. So 83,810,205. That is the result. That is the final example of the column multiplication. Great. Last exercise. As you have guessed it, it's called column division. Alright, let's move on to the first example. This one is 6,382 divided by 8. Alright. So when we do column division, we first take a look at the right number. In our case, that's 8. And then we take a look at the number is the quotient and what is the remaining part. So we know that 7 times 8 is 56. And the remaining part is 7. Now, why is that true? 7 times 8 is 56, plus 7 is 63. And there's one more rule. Whatever remains must be smaller than the divisor, in this case, number 8. For example, if the remaining part would be 8, then the quotient here would not be 7, but 8, and the remaining would be 0 in that case, since we can divide 8 by 8. So, now that we have a remaining here, we need to add the next number, number 8, next to it, and we divide now 78 by 8. So we know that 9 times 8 is 72, and then the remaining is 6. And once again we write the next number down, which is number 2. We divide 62 by 8, and once again we know that 7 times 8 is 56. The remaining part is 6. So we have ran out of numbers here, no more numbers to add. So the quotient of this division is 797 with number 6 remaining. 6 remains. So 8 times 797 plus 6 equals to that. That's great. Let's move on to the next example. We have 62,200 252 divided by 24. Alright, so this time the second number is a bigger number than in the previous case. We have a 2-digit number this time, but that will not be a problem. We just need to look, first at the number 6, which is smaller than 24. So we take 62 and we divide 62 by 24. We know that 2 times 24 is 48, and then 14 remains. 2 times 24 is 48 plus 14 is 62, and 14 is really smaller than 24. Great. Now we add the next number here, and we divide 142 by 24. Now we know that 5 times 24 is 120, and then 22 remains, which is smaller than 24. We add now 5 down to this. 225 divided by 24. We know that 9 times 24, what is that? We know how to column multiply now, so 36, 21, 216. Right, so what remains? 9. Alright, so 9 is smaller than 24. We write down the 2 from here. 92 divided it's 72. It's 72. Yeah. Good thing I checked. Therefore, 20 remains. So 20 is smaller than 24. Therefore, that right, the number right here is the quotient, and 20 remains. We can delete that, and I will just circle the answers. Good. Let's move on to the next example. We have example C, 638,000 divided by 45. Alright, so we cannot take 6 here, we have to take 63. And 63 divided by 45, we can put 1 inside, and 18 remains, right? 1 times 45 plus 18 is 63. That's true. And we put down the 8. And once again we divide 188 divided by 45. Alright, we know that 4 times 45, that's 180. We have 20, 16, 18, 180. Therefore 8 remains. Now we write another 0 here. We just copied it down here. And 80 divided by 45, that's 1 times 45, and 35 remains. Let's put another 0 down. 350 divided by 45. I believe we can only divide it so that the result is 7. Let's see. 35. 7 times 4 is 28. 31. Okay, great. So the result here is really 7, and the remaining part is again 35. So we write another 0 down. And then again 350 divided by 45 is 7. And 35 against remains once again. So I will write it here, 35 remains. And I will delete this one. And by the way, if we would continue to divide this number by adding zeros, we will get like a decimal part. But since we are working with natural numbers at the moment, we will not do that yet. Let's move on to the next example. Example D. We have 100,372 divided by 103. Alright. It's getting trickier. In general, column division is the hardest of the column operations. That's why I left it for the end. 103. We know 1 is smaller, 10 is smaller, 100 is smaller, so we need to take 103. Alright, we know that 9 times 103 is 927. Now what remains? We need to subtract these two numbers to see what remains. So first we have 6 here, 7, 0. Okay. 76 is the number that remains. So 76, we move the 7 down again. And we divide 767 by 103. We can surely divide it at least 7 times. And let's see, 103 times 7. We have 21 here, we have 2 here, and we have 7 here. And 767 minus 721, that's 46. So we put the remaining here and move the next number down, which is number 2. Now we can divide 462. 4 times. Since 4 times 103 is 412. Let's look at the remaining part. It's obvious, it's 50. So we have 50 remaining here. And we have run out of numbers. So 50 remains. So we can see that column division gets harder as the numbers get bigger. Especially the number here on the right. This time it was 103. Okay. Looks like we only have 2 more exercises left. So this will be the last page for today. Example E. We have 728,109 divided by 352. Yeah, this is a much bigger number now. Let's see. 7 is smaller, 72 is smaller, but 728 is bigger than 352. Therefore, we take this number now. If we divide 728 by 352, we get at least 2 and something. Now, what remains is the question. We know that 2 times 352 is 704. Maybe let me write it on the side. 704. Now the remaining part is 420, so 24. Alright, great. Let's put the next number down. 245. 0 here. And the remaining part is basically this same number. So we just copy this and then write the next number down, which is 0. Now this number here is surely bigger than 352. Now how many times can we actually put 352 inside that? Let's try 7 for example. We need to kind of guess at this point because these numbers are pretty big. So let's multiply this by 7. 41, 35, 36, 7 times 3 is 21, so 24. That is bigger than our number, so it will surely 6 must be the answer here. Alright. What is the remaining part? Let's see. Oops, wait. 352 times 6. That's 12. 5 times 6 is 30. 31. 3 times 6 is 18. 21. Alright. The remaining part is 2410 minus 2112. We get 8, 9, 2. So 298, which is smaller than 352. Now let's move the next number down. Now I believe we can put 8 times 352 inside 2989. So let's see, let's calculate the remaining part. 352 times 8, 16, 41, 24, 28, 2989 minus 2816. We have 3 here, we have 7 here, we have 1 here. So this is the remaining part, which is smaller than 352. Now we have run out of numbers. Therefore, 2068 is the answer, and 173 remains here. Let me just recheck that, so I made no mistakes. That is correct. Now the final boss of today's video. We have the example F. Definitely the hardest exercise or example. We have 721,371 divided by 7,281. Let's calculate that. We know that 7 is smaller than this, 72 as well, 721 as well, even 7,213 is smaller. So we need to take this number, which is huge. Alright, now I believe we can put this number 9 times into that and get some remaining 52. 7 times 9 is 63 plus 2 is 64. And now let's just subtract this number from 72,137. Let's see. No, whatever it means, it must be smaller than this. So we have 8 here, 0 here, 6 here, and then we have once again 7 here, 0, 7, 6, 8, which is bigger. So we made a mistake somewhere. Wait. That's 9 times 7 is 63 plus 2 is 5, yeah. That's a mistake here. So this is 5. I mean, yeah, this becomes obviously 6. So that makes sense. Now, alright, that's the remaining part. We can write it down. 6, 6, 0, 8. And then we move 1 down there. And once again we divide. As we see, it will be able to fit 9 times again. And the remaining part will be after the number we get when we subtract these numbers. So 6, 6, 0, 8, 1 and 6, 5, 5, 2, 9. Let's see, we got 2 here, we got 5 here, we got 5 here again. 552, I believe. This is the hardest problem of the video, so 552 remains. Let's check if I'm right. So, yes, that is the correct answer. So these are final results. And that is all. That is all for today's video. Thank you for staying for so long, for watching the whole thing. And I surely hope you subscribe